Prove that u dot u equals the magnitude of u squared. All right, so first thing to do, we have to have a way of talking about just some general vector u, because they didn't tell us much about u at all, right? They told us just vector u. So we need to be able to talk about what is vector u in a way that we can actually work with it. So let's just give the components names, right? So we'll do it the same way that has happened in all of the previous stuff, where we've just said first component is u1, so we'll make this u1. And then the second component will be u2, and then the third component would be u3, and all the way up until some un, right? Because every vector has to have some specific length. It's not allowed to go on forever, so we'll stop at un, which is n will be just the length of our vector. So this is going to be the case for any vector at all. We could put it in this form of first component, second component, up until its last component, which we'll say will be its nth location in the thing. All right, so now we have a way of doing this. Let's just look at what is u dot u, and then what is the magnitude of u squared. If they wind up being equal, we've proved this thing, right? So u dot u would be vector u1, u2, up until un, dotted with u1, u2, up until un. All right, so u1 times u1, well, u1's just some number, so that's u1 squared, plus u2 times u2, well, u2 is just some number, so that's u2 squared, plus this is just going to keep happening until we get to our final component, un times un, well, un's just some number as well, so un squared. So we've got u1 squared plus u2 squared up until we get to un squared. Now, there's not much we can do to simplify that there, right? So let's take a look at the magnitude of u squared. So first, what's the magnitude of u? Well, magnitude of any vector, remember, is each component squared, the square root of each component squared added together underneath the square root. So it would be the first component squared plus the second component squared up until the final component squared, and all of that underneath the square root. Well, if we square this, then we got u squared, magnitude of u squared equals, well, if we square both sides of that equation above, square root times square root cancels out, and we've just got u1 squared plus u2 squared up until un squared. Well, look, this and this are the same thing. So since they're the same thing, we've just shown that u dot u is equal to the magnitude of u squared. Great, proof is finished. All right, so that finishes up for the examples. Thanks for coming to Educator.com, and we'll see you in the next lesson when we start talking about matrices. All right, bye. All right, I think they're gone, everybody who's not actually interested in the proof.